Hello viewers, I'm Dheeraj Chawda, and today I'm going to do an experimental based video that is about hardness. So we want to go to the hardness part. We will first understand why hardness of a material is to be required. For it is a process called material testing. In medic industry, you see many components, and you may be wondering why they are using this component or these specifications, and why are they using this component for this actual art making. So the process is called material testing. So yeah, in order to test a material, there are many. You can say there are many tests performed, like tensile tests, compression tests, hardness tests. Then also based on their chemical properties, physical properties, mechanical properties, also even electrical properties. So one of the properties that we are going to see today is the mechanical property. In this mechanical property, we are going to see about hardness. So you will be wondering, what is hardness? Hardness is the resistance to the indentation. Suppose this is a chalk. Okay? Now, if I apply pressure, it is not this. Or normal pressure I am applying towards the center, but it is not breaking. As soon as I apply a maximum force, it will break into two parts. Easily break. And this thing is like very brittle. This chalk is very brittle because it has a property of brittleness. So like this, every material has this property. So basically, what you can understand is that hardness is the resistance to the indentation. Means if there is some scratches, the ability of the material to prevent scratches. Means small marks are there when you are flying. As being an aeronautical engineer, we are flying towards the aircraft due to some wind and due to some other factors. There may be a disturbance into the component, or there may be cracks or any bends, dents, etc. So in order to avoid that, we are doing this hardness test. So this hardness test has three experiments. Three experiments means in three ways we can conduct that experiment. The three ways are Rockwell, Brenner, and Vickers. Out of which today I am going to show you the experiment that I told you in the earlier video was Rockwell test. So I will now walk you through the equipment is speaking about. This is a Rockwell hardness testing machine. So in this machine, here and we will test various specimens, and out of it I have two specimens. So this one is aluminium and this one is brass. So today we are going to test aluminium as well as brass using the Rockwell hardness machine. Now in order to do the hardness test, first we have to understand what is this Rockwell hardness test machine and what are its various components. So let us start one by one. So this one is called the anvil. The anvil helps in going vertical. As you can see, we can go vertical as well as downwards depending upon our specimen on the material. Second is that the dial gauge. The dial gauge has a red reading inner side and a black reading at the outer side. And in the inner side, we can see a small dial. This dial tells us that the minor load applied should be not greater than this three mark, as you can see in the red dot. As we move behind, we have an instruction saying that the dial indicator may get damaged if the small point goes beyond the red dot at 3. As I said, the minor load or the load applied should be not going greater than these three values. Next up we have is the load applying part. This load applying part has a load selector. The amount of load we want to apply to our specimen, depending upon the Rockwell hardness scale, is given over here. So it is starting with 60 and 100 kilo. The unit is kgf, which will be later converted into Newton. So it's from 100, 150, and the maximum we can apply is 187.5. So this is the load selector. Now, here we have a scale. This scale is very important when we are doing our experiment. Depending upon our material, like suppose my material is a thin steel. So I will choose a indenter diamond one and apply a load of 60 kgf, and the dial reading should be noted from the black end. So the black dial, as I showed you earlier, we will have to note the reading. Now we have our two specimen, that is aluminium. So the aluminium, we will choose the indicator 1 divided by 16-inch ball indenter with an applying load of 100 and seeing the red dial. And we will have a scale called B. So when we are calculating the units or the amount of load applied, we will have a unit called HRB for aluminium. Suppose the aluminium mostly have a value between 0. So the unit will be HRB. So next is the mounting of indenter. Through this, we can mount our indenter from this part, and with the help of Allen key, we will tighten the indenter. So now we will understand the experimental procedure of this Rockwell Hardness test. So in order to perform this, first we will rotate this anvil towards the upper side, and then according to the table, as I am using the aluminium, I will select an indenter of 1.6 and will apply a load of 100 and see the red dial. So now I am placing my aluminum. This is an aluminum test piece. So the indenter is not available now. So afterwards, after this indenter, suppose this is an indenter applied here, I will fix this indenter on one point. After this, first I will apply a 10 kg load, 10 kg minor load. Because of the 10 kg minor load, a small indentation will be occurred in the aluminum test piece. Now, if you come closer and see this, I have performed this test earlier. So as you can see, these are the indenters. These are the indenter holes you can see, or marks you can see on the test specimen. After performing the experiment, you can see such kind of indentation over the material. After that, as we know that according to the scale, we will apply a load of 100 kilogram F. Now this is an unloading and loading system. We will apply the load of 100 kgs. Now, then we move to the dial gauge and we look at the red dial. After looking at the red dial, we will know the readings. We will get a certain value. We can get till 50 or 60 or 70, and the rotation can be seen over here. After the load is applied, we will unload this. We will unload this. As you can see, first it was loaded, then now it is unloaded. After this, we'll see the dial gauge again and it will show a reading. So that reading on the red dial gauge is our hardness of the aluminum specimen that I am using, this one. So in this way, we will conduct our experiment and we will get a value of aluminum, and the unit of the aluminum hardness value will be HRB. HR means hardness Rockwell number, and B indicates the scale, HRB. So in this way, we will conduct our experiment on Rockwell Hardness Test. Thank you all for watching.